There
There we
we
go.
go.
Now it's up.
Hello there. All righty. Let's get things live and rolling here for Tooltip Tuesday. There we go. Hi, everybody. It is me, Jennifer from Little Metal Foxes. And of course, I've got
Julia from Little Metal Foxes.
and Helen.
Helen from the Little Metal Foxes.
We are very fortunate to have Silas Morgan from TechForm Casting down in Portland, Oregon, joining us today. So, Silas, how are you today?
I'm good. How are you doing?
Doing good. So I just want to say, and I said this earlier to you, that for years I have said, to my students and to other casters, I'm like, you really have finding a good casting company to work with is like blind dating. You just have to get out there and give it your all, and test the waters, see what's the good fit, and if it's going to be a long-term relationship or not. And because they're not just going to walk in your door. And about 2 weeks ago, I was over at my friend Peggy Foy's studio with another jeweler friend, Tisha Abramson, who has been on with us as well. And in comes you and Joel into Peggy's studio to talk about TechForm down in Portland, of which I'm very familiar, and I love to hear more about it. And we were very lucky, Julia and I, when we were down. I think Helen, did you go to the SNAG conference in Portland?
I did.
Right. So I believe that was it Teresa that actually spoke at the SNAG conference. So we actually heard her speak down there, and I was just floored, absolutely floored by her. She was amazing. So very happy to have you here and talking a little bit about TechForm. So real quick about you, Silas. How did
on the spot?
How did you start this journey kind of quickly into getting into TechForm?
Yeah, so I just graduated a year and a half ago from MBA in finance, but my background is much more technical than that. Finance was more so, you got to understand the nitty gritty.
You've got to understand the business.
You got to
do anything with the other stuff in your head.
Yeah.
It's really what it is, right?
This was what I learned. I've been in the wine industry a long time, been in geology, and when I saw, what differentiated a successful business and an unsuccessful, no matter the product, it was how you manage your business and how you sold things. Because you can make all the jewelry, you can make all the wine you want, but you have to sell it and you have to manage your business correctly at the end of the day. Otherwise, what are we doing here?
Right.
But
you also have a technical background as well.
Yes, exactly. So my background was in geology, specifically in geochemistry. So mostly looking at acid mine drainage, and that's so that the aftermath of actually extracting resources from the earth, particular like hard rock resources like metals. You tend to pulverize a lot of material, and it interacts with the water table usually because you're going subsurface, you're going into the earth. So when you abandon a mine, especially, you get interaction with the water table, a lot of dissolved, mostly metals. And mostly acids. So you get because water is slightly acid, you get these metal ions transported in high concentrations. That's when you see the classic, iron oxide staining coming out of an old mine mouth. So really, really toxic tend to be. So it was really interesting studying those, did a lot of work in Colorado on sites I got there. But ultimately, know a lot about petrology, rock formation, grain size, crystalline structure. So yeah, it's a great fit. When I was back out here looking to leave the wine industry, it was perfect timing for Sarah Loveland, who's the second generation leader of TechForm, was looking to expand. So it was perfect timing. I'm happy to be here.
Awesome.
That's lovely. Yeah. I mean, I love the crossover. Science is science is science is science, And
absolutely. It's a universal language. Same with math.
Yes.
Exactly. And so if you have a strong foundation in math and science, and now you have the business side too, it's like, no, you're TechForm is lucky to have you.
So speaking of TechForm, I know that TechForm is renowned for their high-tech casting, starting in medical and aerospace casting, and developing into jewelry and precision casting, especially with like platinums and other challenging materials. What kind of, from your perspective at TechForm, and I know you've only been with them a few months, and this might be a better question for Joel if you drag him over there. But what kinds of casting technology differences have you seen develop in the last couple of decades, possibly, that have gotten TechForm kind of where they are now? And just kind of like in the evolution of casting. Where
I would
yourself?
I would say it's definitely, I mean, 3D printing is a major one. Even in the last year, we brought on flash forge printers. That was after using ProJet. I mean, but if you even compare that to, we still get quite a few waxes, and the variation in quality when it comes to hand carved is just extraordinary. Some people are absolute artists when it comes to hand carved. Others, you're going to get what you put in, to a certain degree, especially with our casting technologies.
All the flaws
that
you couldn't see.
Yes, exactly.
In the hand carving will be replicated perfectly in the casting. That's what you're saying, right?
Yes, exactly.
And
I've seen that firsthand. Sometimes we get.
Yeah, we refer to that as SISO and the casting shop.
Yes, exactly. And so, but to a certain degree, it's the same thing with 3D printers. And we were early adopters of 3D printing, and I've actually seen some of the samples from maybe 12 years ago. And the surface texture is really rough. It's poor. You can see the grow lines are, the overall shape is net perfect, but you look closely and you instantly see the issue, which is you're going to be working
even with the naked eye.
Yeah,
even with the naked eye. And I mean, these are 12-year-old technology.
Right. And so now today,
the flash forge especially, we see it's less so a specific dimension, like the ProJet, for instance, was mostly in the Z dimension. And you can adjust your orientation in the printer itself to kind of compensate for that, so you don't have like a buildup of superficial roughness and really hard to reach spots. But now with this flash forge, we're really happy with the exactitude, but also just it's a really fine texture that's just widespread. So it's like, you just expect to work through a little bit of cast skin, but it's once you get past that, the metal is amazing.
So really, the artifacts left from the printing are something that are minute enough, simple enough, and universal enough you can polish them out.
Correct. It's not even, I wouldn't even call it artifacts. It's just a general roughness.
The general texture
is the texture. It's printing texture, but it's so fine that you're not going to see individual striations like you would with.
Well, and it used to, 10, 12 years ago, it used to look like cuttlefish bone casting. Because it was like you could
literally it literally is like that kind of the stacking, especially
like 8-bit versus
And so I mean we just see that those technologies rolling out, and a lot of that is unfortunately due to some of them going out of business. And so it's it's a pretty I think tough business to scale up. You sell these machines for tens of thousands of dollars, and then have appropriately priced services. I think that's where they really struggle. It's like once they get the machines into a shop, then to like appropriately price and service these machines, have the appropriate warranty, because they do. The earlier ones were breaking a lot. Like Solid Escape, for instance, we had to tinker with those every day to get good printing.
Well, and you've got at a certain point, casting has ancient traditions that go back 6,000 years, and you were working on something that is absolutely cutting edge, and trying to blend those two, that traditional part with this high tech part, to get a really good product. And the craftsmanship of that is really important, and really drilling down on all those details. What can, if you were an educator in a school where you've got students learning how to do casting, and they're usually using something that is an older casting method, like centrifugal casting or vacuum casting, to achieve their ends. Some of them are doing 3D printing, some of them are doing wax carving. What kinds of things would you want to kind of let educators know or students know that they might want to prepare for if they're doing this kind of high-tech casting? What are the kind of pitfalls that that new people coming right out of school may not have experienced yet, with that experience of the high-tech world, that they're what can they better do to prepare for that experience?
Yeah, let me just ask a question relative to, because basically what you're saying, Jennifer, is that what's available to the schools is never going to be the cutting edge high tech options. So it's like
they do have a lot of the high tech options to do the 3D printing and to design on computers, but they don't all get that.
Mm-hmm.
Okay, and then the casting is fairly low tech.
And the
is that what you're saying?
Yeah, is low tech or centrifugal or vacuum casting in most cases. So you've got these things going on at the educational level, and now you've got a whole new world of casting technology in the last few years that is kind of revolutionizing how things are being done in the industry. So what kinds of things would you recommend that students maybe take an additional class in, like CAD/CAM or stuff?
That's exactly what I was going to say. I mean, you don't have to be, an expert at CAD/CAM. I think it's really difficult to get there, to be honest. But at least understanding what's possible and being able to have some sort of lexicon. So when it will honestly reduce your costs at the end of the day. So even if you do have to work with a more seasoned designer to really refine your design, it's going to save you time and effort just from an editing and a collaboration perspective. Even if you don't feel confident enough to say go through and do a full design from scratch. But that's the future. I mean, even if we get, say, a physical reproduction, say, of an antique ring, we prefer to push it through our partners who have high-tech scanners so that we can render it in CAD/CAM. Because at the end of the day, that's going to give you the full control of being able to sprue and file and also scale and file. And I think that's the biggest difference is, and I'll be real open about this, is we like to sprue in-house because we are very attuned to metal flow and exactly. And that's where a lot of porosity and issues come from, is people under sprue. And we get sent this all the time. We get waxes with a single sprue feed at the bottom. And we just look at it and we're like, no way. This is why you're having issues.
Yeah. Well, and spruing, it's like, everybody feels like there should be a silver bullet. And I'm like, there's not one cure for any casting. You have to, every single one of them.
No, exactly. And we're making extremely informed decisions when we look at each individual design. But there's still some times where we look at the casting, we say, yeah, I don't think this is fed correctly. We need to re-sprue it. We need to rerun it. Because we make those mistakes. I mean, not very often, but I would say Joel is an expert at that. He can look at a file and just, magically sprue it.
He can be like, yeah, no, that's not where it's going to go. It's going to go over here, 2 millimeters. And then
it's rarely what the customer is provided, honestly.
Right.
And some of that's that we have enough, metal reserves to put a lot of metal that's not going to be in the finished piece into the casting. It's not a big deal for us because we have really tight systems where we're going to revert a lot of that. We're not putting a ton of new metal into the system.
I refer to that as the art of the unseen.
Yeah.
Because a lot of times people think that the finished piece is magically doink into wax and doink into, and I'm like, well, no, you're going to have, there's a lot of work between this and this. And a lot of that is understanding the sprues and how the metal flows and everything else. Seeing the mold from the inside and understanding how it's, the metal is working its way through.
Yeah, and we're protective of our sprue designs, but it is kind of, I think, one of the key ways we have a lot of success with our castings, to be honest.
Yeah.
And so I wouldn't discount that when you think about sprue architecture. You need to think about metal flow, and you need to think about how, especially with platinum, we're talking about, freezing temperatures that are so high that it's seconds. Blink of an eye, you have hardening, you have grain size development. You have very minimal room for error.
It's got to get in there fast. Yes.
Got to get in there fast. I mean, it's also got to get in
hard fast.
Especially with prongs, really fine filigree. It's, this is seconds, and it's got to get in there at the right point at the right time. And
And enough pressure.
Yes, exactly. Yeah, we're talking about high pressure environments.
Yeah, so many things with platinum.
So that's one of the things that's very different than what you do from what like a student would have access to, right? Because if they're doing centrifugal casting or vacuum casting, you're doing high pressure casting.
I mean, yeah, we do centrifugal, but it's under pressure.
Mm-hmm.
It's not a wholly different category than I think some of these students have access to. A lot of it's also down to our ceramic coating. We're very protective of that. That's something we develop in-house. We do a coating that we worked with like a PhD ceramicist to develop ourselves. And so that's a big key as well. And that keeps things really clean. So there's not very minimal silicon contamination. And that's the other problem. It's like a lot of cracking, a lot of poor platinum casting. It's because people are not using the appropriate temperatures and tools, getting contamination. That's ultimately what a lot of cracking comes from. Is you have, it's really interesting when you read the metallurgy reports, you get, when the final frontier of solidification is happening in your ring itself, that is where all the contaminants are concentrating. And so that's where even a minute amount of silica will concentrate at that last remaining liquidus point and crack, because you have maybe 70% silica, but just at a minute scale.
It becomes like a grain boundary and like
exactly
in a wall of granite. You've got that, just like you end up getting that water leakage that comes into like too big, blowing this up into geological form. But you get like the grain boundaries that are trying to form, and then you get something in between them that causes a break.
That's right. That's right. When we talk about like the dendrites forming, when the common grain structure, which is commonly dendritic, is forming, you have the interstitial, and they're growing from the liquid, right? So, as it's growing, you have it just push to smaller and smaller spaces, but that's where those contaminations, those non alloy components are concentrating. Yeah, we call that the interstitial or the interdendritic.
Yeah.
Are these contaminants in the alloy, or are these in the investment?
Usually it's coming from the investment. And that's ultimately why we coat. And this is less of a problem, right, with other alloys, but this is, high temperature, high heat, high pressure. This is being thrown at, high speeds, high temperatures, and
specific. Are you using specific gases, or are you using induction?
We use argon.
Argon.
Yeah. So that's the other thing, especially cobalt is reactive to nitrogen, and we cast multiple alloys, including platinum cobalt. But there's other, any sort of gas is going to interact with atmosphere. The atmospheric gases are just not ideal to be in this sort of environment. It's best to have these heavy inert gases totally covering it. Yeah.
Oh my God, platinum.
I know. So Jennifer has a ton more.
Let's cast gold.
Jennifer, it's interesting. We've actually kind of strolled into gold, right? Because it's in a lot of ways it's much more approachable than platinum, but we've also been a learning curve a lot. It stays liquid for so much longer. When we first did it, we were like, oh my God, it's so
sweet.
It's a luxury.
It's so nice. Yeah. It's so cooperative most of the time.
Well, it's so funny because then we talk to people and they're like, oh my God, I can't do this large flat surface. And you're like, really? We just did it, no problem. So we feel we kind of pat ourselves on the back sometimes when that happens. Yeah.
Really?
Well, we also developed. We use hot isostatic pressing. I don't know if you guys are familiar with that.
Oh yeah, tell them about that, because this I found fascinating.
So this is from our aerospace and medical background. If you're putting something in the body, you cannot allow for variations in grain size or internal porosity. That's a huge no-no, right? And so hot isostatic pressing came along, and that's where you put it into a really thick walled chamber. Pretty much you pump it full of inert gas and you bring it to high temperature and pressure, and what that does is kind of reactivate the grain boundaries without actually remelting. And so what you get is a collapse in internal porosity. It just purely collapses it. And that can be a problem sometimes. If there's a pore space really close to the surface, you'll get pitting, but it's repairable. And ultimately, it's better than going into finish and you have all of a sudden huge areas of porosity that you're dealing with.
So it's basically kind of like vulcanizing the metal. Like heat and pressure, just
in a way. I mean, it's ultimately pressing, right? Like you're pressing it, but it's high heat and pressure. But very dialed in so that you're not, say, regrowing grains, because that's a huge problem, right? If you're, say, annealing a metal, you can go a little too far and actually start growing grains, and that's a huge issue, as many jewelers know. It's very interesting. It took us a while to dial that in for gold versus, because we're so used to platinum. It's a shorter cycle, it's lower heat, but we're really dialing that in, and we're one of the few jewelers to really use this because it's they're multi-million-dollar machines.
Oh my gosh. Well, what is would you say, maybe, is there a project that you've worked on in particular that has been especially technically challenging for you all that you can think of, that is like in the jewelry world? Because I know jewelers can give you things sometimes that it's like, that's not castable.
Well, this is a tip I would give to especially a lot of younger jewelers. And this kind of comes in with the CAD CAM recommendation. I would say start with your caster as soon as possible if you have questions about castability. Just shoot it. I love it when people shoot us a message and say, "Can we actually fill this? Can we do this?
Is this even
possible to do this?
Am I crazy?
Or how do we do it?
This?
Right? It's like so many people say try to cast all in one piece when you should, or vice versa. They try to break it up and make a headache for themselves, and it's just best to talk to people who have been doing it like Joel for 30 years, and they can say right off the bat, like, "Oh my God, no way are we filling that," or "That's going to create problems." Like the biggest issue for us is people leaving, say, minute gaps. And that's where either investment or our coding, no matter who you go to, whether it's coded or just investment, you're going to get a higher proportion of failure, because if you think about it, with the lost wax casting, you're getting a tiny little sliver of whatever material you're using.
Oh yeah, that sucker wants to break off and just fly over to some other part of the mold.
Exactly. And that's like when we talk to people, it's like they get it, they realize it pretty quickly when we explain it to them. But these are oftentimes jewelers who've been doing this 40 years, and you're like, think about it. You got to think about how the metal is going to come into this system.
You have to think about what the negative space looks like, right? Which is really hard because we're so used to looking at the positive version.
Right. I explained it to the students, and I'm like, if you've ever seen, not that anyone nowadays has seen this, but Indiana Jones and the Temple of Doom, and they are on this roller coaster that's going through a mine, and there's stalactites and stalagmites all in the mine, and there's water crashing behind them. I'm like, that's what's going on inside your mold, is you've got this giant thing of water that is coming into this cavern. And if it hits something in the wrong place, it's going to spread those stalactites and stalagmites into the water with it, right? That's what's happening. So if you have those things, the metal's just going to shear off all those little tender points, and they'll be floating around with your metal. So then they're like, what? Because they're going to be times when they put the sprue in the wrong place, and it's just like directly across their, texture. And they're like, why did it break off? And I'm like, well, you've got 3 G's of metal going into a hole that's going straight across those little knife edges. So
that's a good way to put it. Honestly, that's a good illustration.
You really have to kind of think inside the mold and what's actually going on inside of it.
No, and it's the same thing with spruing. You think, okay, if stuff is cooling off rapidly, how do I feed it to specific sections? And you can look at, say, a head or a shank, and say, okay, this needs to be filled appropriately. So where am I going to sprue it? It's basic logic, but you need to think about it, the negative space, and that's difficult for a lot of people.
And knowing what your parameters are, knowing what you can get away with. And so I think one of the nice things about having students in a classroom where they can really kind of push the boundaries of possibilities, and they by doing that kind of learn, okay, If I go too far this way, it's not going to work. If I do too much this, it's not going to work. So they can kind of really experiment with those in a way that gives them an understanding of how things are kind of coming together. Instead of kind of going, this is how you do it, ... and never really understanding what those parameters are, what exist outside of, this thin line that's like the perfect solution. And I think we all know that in casting, there's never a perfect, like,
no, and that's the other thing I would bring up is shrinkage. Yeah, it's really difficult. When we're proud of a piece, it's usually a complicated piece that has a lot of dimensional restrictions. Maybe like a two-piece ring, for instance, like a two-finger ring with like a nested component, and that's extremely difficult because not only are you talking about just a large mass of metal, so you're going to have quite a bit of shrinkage just because the larger the metal mass, the more shrinkage you have. But it's also kind of an unknown. How is you have two ring finger sizes to really accommodate and try to scale appropriately, but you also have that nested component. So when we have projects like that, I think, and we nail them, we feel really good coming away from that.
Yeah, those are big challenges. And I think one of the other misconceptions about that shrinkage, it's not like things shrink like a Xerox copy. It's not like you'll put it into the computer and go, reduce that by 50%. That's not what happens. And it's going to shrink in kind of on itself and in weird ways. And it's never completely like, yeah, it's going to shrink by 5%. And it's like that 5% may all be in one spot. It may be.
Yeah, and like, so yeah, for instance, when we think about like a large chunky engagement ring, we'll start with 1%, for instance, and we'll kind of go from there. And sometimes we have to redo it. Sometimes we'll just see the design and say, okay, there's so much mass in this one dimension, we're actually going to scale a little bit more because we just expect it. And we also have to think about how are the sprues going to interact with this? Because if we're spruing, say, more than most people, that's just more metal mass, and that's going to interact with shrinkage quite a bit. So you need to think about it as like a kind of cohesive system about when is shrinkage taking place and in relation to what.
Right. Cool. Awesome. Okay. So I think that from kind of the caster's point of view and the student's point of view, that's good advice. Thank you. What piece of advice would you share with anyone who's even old pros and people like that who are coming to have something cast, possibly early in their career, whether they are just tired of casting it themselves or a student who's been is new to this? What advice would you give them when approaching a caster for the first time?
I would say understand what you're getting for the price, because I mean we're pretty open that we're not the cheapest out there, and there's a lot of options out there. I mean, we were just talking about a competitor in India who was putting out an infograph displaying that he was still the most inexpensive option even with the recent tariffs. So there's an extraordinary difference in cost, to be honest. But the quality kind of speaks for itself. So it's how much repair do you want to do, and you just have to understand it, right? It's just different value propositions. We're saying, hey, we know how to do platinum really, really well. We know how to do gold really, really well, but there's labor involved, as we're kind of talking about. To be that kind of tight from an operational perspective, it's a lot of labor. And labor in the United States of America is not cheap.
and a certain level of expertise. You've got 30 years of expertise with alone. And I mean, that does not count for nothing. You've got somebody who's seen a lot of stuff in the past, has seen, and this is basically when I was working with James Manchiteri at Outcast. He had been doing this for 30 years as well. Yeah. And I learned, I felt like I had a whole nother master's degree when I got done with him as his lead caster, because he had seen so many things come through that
So many things go wrong, I'm betting.
so many things go wrong, and how to fix those problems and how to head them off at the pass, and what works best with what. And so when you're paying a caster to do this for you, you're paying not only for the metal, which a lot of people are kind of like, well, the metal is only this much on market. So, it's like, yeah, but you're paying for all the materials that, for the flask.
The coatings and the investments, all of that.
Films.
Yeah,
and it's really difficult for people who haven't maybe done that. I mean, as you said, like newer people who haven't done the full process, perhaps, to really understand, because they're used to maybe just getting a ring. Like you order something, you throw in a CAD file, and you get a product. And it's hard to, I think, from that perspective, unless you have a lot of experience, to understand the difference between what we provide and a classic like clip and ship. Because clip and ship, you're going to get more metal because they're not cutting sprues and stuff like that. So
yeah,
that's the biggest thing I would say is understanding just what it means to you, the difference between the casters out there, because there's a wide range.
Yeah, there is. The and each service can be an add-on, right?
Yeah.
You kind of do like certain finishes will continue to sort of like a la carte yourself up in price a little bit. But
yeah, and we're even considering that, like how much. But once again, it's more labor.
yeah. So it's one of the things that I would say is to really look at it as a collaboration, and that's why I use the analogy of like blind dating because you really do have to get to know what the casters can do, what their turnaround time is, how much it's going to cost, what the quality is, if you can deal with the personalities, and are they going to work with you the way that you want to work, and give you the quality that you want to get in your pieces. How much work do you want to do on it, or do you want them to do the work? That's all those things make a big difference. So if you're in a bad relationship, with a cat.
It's fascinating. I talk to a lot of people who they're like, well, my gold's good enough. And I'm like, okay, if you want to settle for that, that's your prerogative.
Yeah.
At the end of the day, if they're comfortable with their turnarounds, if they're comfortable with how much welding they're doing, it's up to them ultimately.
Yeah. Well, and it's there are starting places I think that are like small. Let's work in small just to get started, and then I think sometimes for people who are learning the craft of making, it's a little bit different than people that are doing the design.
Yes.
And working through the design level. A lot of times, the designers that I know that do this, oftentimes don't ever touch wax or models or anything. They're doing it all on the computer, sending it out, having it cast, and they have stone setters put the stones in, and they come up with extraordinary jewelry pieces. But it's a very different way of working than having your hands on fabricating or wax carving. It's just two very different worlds. So,
and we work with both, to be honest. We have partners who still send in handcraft waxes, single person shops, kind of the classic, independent jeweler, and then we have people exactly what you're talking about who maybe aren't even from jewelry and are building a whole brand.
Really, and a whole line, and are like, we want you to cast, multiples. It's a production thing. We want fan molds. We want whatever, right?
Yeah.
As opposed to somebody who's like, I've carved this ring for this person. It's this very specific thing, and I need you to cast this one thing, and I need it to be this size, which is a completely different animal from.
Yeah. Yeah, and I appreciate both approaches. It is interesting, I think, especially I'm sure you all have seen this, but everyone I talk to, they're all saying custom, custom, custom. Everybody, even the high throughput stores, it's like millennials especially, they want something unique. They want a unique value proposition, and they don't even want a repetitive design. They don't even want to choose from like a lookbook. They want to say, I want to build something from scratch.
Right. Yeah. Well, that leads me into my next question. What do you see working as getting as much in and out as you do? Are you seeing trends with that kind of design or specific metals right now that are sort of trending?
Yeah, I mean, this is also what I talk to all my customers about. I mean, this is why I was in Seattle. It's so good, I think, to touch base with people because, in the day to day, we're a manufacturer and we don't always hear back even from a client who we do weekly business for. So it's great to touch base and see even what the trends are. Obviously see it through a lot of the throughput, but to see them and say, maybe we're not casting all their metals for them. So really to understand from a retail perspective what the trends are. Yellow gold, number one, absolutely. Everyone's going back to yellow. Rose seems dead. Yeah.
It had its moment, and now the cycle has moved on, I guess.
Yeah, exactly. And the biggest thing we're kind of struggling with is, with the prices the way they are, is why isn't there more platinum demand? And I think a lot of that is because there's a connotation around finishing, right, and working with it compared to white gold. And we're always kind of struggling with that because we're actually testing white gold right now, and it's not that. I mean, it's easier in some regards because it's low, right?
I like the palladium, white gold, like 18-karat palladium.
See, this is interesting because we've talked to. I just did a big canvas, of our biggest customers, and it was like split 50-50. Half loved Stoller's X1. The other half hated Stoller's X1 and said, "Please give us a palladium bearing." Like, it was really interesting.
So say more about Stoller's X1. That's an alloy. And what is it? What is it? An alloy of what?
It's a white gold. It's a 14K white gold. It's a nickel bearing, pretty classic white gold alloy.
So it requires rhodium plating, I'm assuming.
They suggest it does not, which, we don't plate, period.
Right,
so it's really not, it does, when I've seen samples, it appears less, yellow tinge, but I haven't seen older samples. So like, that's classic, right? You tends to yellow with wear.
Yeah.
But with or
the big
without
thing is the nickel, right?
Nickel's the bleaching element.
Yeah,
right?
but it's so, I know in Europe there's no nickel alloys in white gold, right?
You're getting towards its toxicity or reactivity to people.
Right.
Yeah,
exactly.
And that's why a lot of people avoid it, is because then they have to, deal with an allergen, a known allergen.
Well, and the other reason that I really like palladium is, one, you don't have that reaction. It casts like a dream compared to anything that's a nickel bearing alloy, but the color is just, it's almost lavender white rather than the butter yellow and or cream, kind of color that you get with the nickel bearing alloys. So it's a much it's a really cool color compared to like the nickel bearing alloys. So, but it's so much easier to cast from what I found. And so anyway.
See, we would love to do that. I mean, we're testing lots of alloys, but it's funny that so many people have requested X1 specifically, and I don't know, it's just name brand recognition or what. But we prefer to work with any sort of platinum group metal bearing alloy, to be honest, because we know it's a known entity. I mean, we were just casting 950 palladium. Like we know how to cast these metals.
I love it. I love it. Well, Silas, thank you so much for joining us. I'm sorry Joel couldn't join us, but tell him
I'll tell you what he's working on. He's down in the basement tinkering away. He's trying to get an elutriator working, which an elutriator is a fascinating device. It's pretty much a continuous flow, like column vortex. So it's to separate small grains based on density. So it's really to run our, say, our tumbler waste through and get a pretty high percentage of just pure platinum out of it.
Sounds like a Rick and Morty sort of machine.
Elutriator, yeah, no, it does. But you should look it up. It's really interesting. There's a lot of homemade ones because it's extremely effective at. It's one of the more effective methods at chemical fine gold extraction. Really fine grain size, I should say. Because otherwise, it's really challenging to get that from, say, traditional sluicing or technologies like that. Because it's just so fine, it tends to just stay without like a very specific flow and understanding your hydrology. You're going to get it's going to stay suspended. So it's really cool. You should look up some YouTube videos of it.
Cool. All right.
I know a couple of friends would forgive me if I didn't ask this question. As far as your sustainability is concerned,
Oh yeah.
in your environment there, what kinds of efforts, technology, processes do you embrace there, or have you embraced in the last few years that make you all more greener, sustainable sort of casting?
Absolutely. I mean, all the platinums we use, all the alloys, they're all 100% recycled. So which is, platinum is a unique supply chain in that regard, because, there's only, technically there's 4 major deposits of platinum worldwide, and they're all pretty tightly controlled by major corporations, because you can't wildcat mine platinum. And I love this because a geologist, and I have a lot of friends in the mining industry. Yeah, and 70% of it is one igneous intrusive complex in South Africa, the Bushveld. So it's incredibly tight supply chain. Not only that, is that platinum is pretty much infinitely recyclable, and a lot of this is coming from jewelry, but also catalytic converters. And so there's a lot in the world that's just being constantly recycled. So it's a lot cleaner in a lot of regards than gold.
Right.
So there's that just from a basis, but we also, as a small business, we do certifications that are really not expected of even small, mid-size, a lot of large businesses, ISO, the RJC. So these certifications, you have to document your processes, your sustainability, all your supply chain to such a forensic detail. And this is really required by some production partners specifically, and specifically with gold.
Yeah.
Gold is so messy. And we really wanted to do that from the get-go as we were getting into gold, so that we honestly didn't have blood on our hands.
Good.
It's like start clean dirty, and then you can stay clean. Yeah.
Yeah, and so we wanted to start off on that, and part of it is also trying to keep exactly what I was saying, keep our processes really tight, so we're not constantly introducing, even from a cost perspective, but from a sustainability perspective, trying to keep our revert really clean, try to keep our systems really clean, so that we're only introducing as much metal as we need to. And some of that's just from shipping and refinement. Refinement is the other major energy suck in our industry, to be honest.
Yeah, and it can be really dirty, and it's one of those things that you really have to have a lot of people that take great care and knowledge to make sure that is, and responsibility for minding that, and not being like, oh yeah, just slap it together and throw the rest out back, and not just ending up with a large amount going to some sort of landfill or into a river that ends up contaminating the environment. And
exactly, and that's what we choose our metal suppliers really carefully, and they're part of these certifications because we have to scrutinize their practices as part of our supply chain. So it's really challenging. The opacity we ran into when we first tried to start doing this, and they were kind of, some of them were standoffish, and it's like, well, you need to be transparent. You need to, this is what the consumer demands, and as they should.
Yeah. And that's one of the other things that I always tell people that if you're buying an engagement ring, if you are out there, casting as a consumer, not just as a jeweler, but as a consumer, are purchasing something, and, get that certification, get those, that clear to the person that you're buying it from, that those things are important. And then the industry is going to have to, live up to those standards if people are demanding that. So,
it's like demanding organic. They're going to put, every Safeway has an organic section now, right? Like when we first started getting organic vegetables, everybody's like, no, they're too expensive. It's like, enough people ask for organic.
Julie, if we see each other next, I'll talk to you more about organic. I have some.
I know, having been a little bit in the industry, yes. I mean, I know. Yeah.
But at the end of the day, you don't have glyphosate. So anyway.
Exactly.
Anyway, but Silas, thank you so much for joining us today and sharing so much information. It is a delight to talk to you again, and I hope that we can talk to you and maybe Joel in the future, and get you guys together and talk about maybe one of Joel's favorite tools, maybe.
Oh, actually, he did pass on his favorite tool. So let me, before I leave you, this is Stuller's, this is their zirconia line of burrs. So I actually love this too, because I like zirconia. Zircons are a really common crystal that you use for dating the oldest rocks on the planet. So, anyone who studies geology studies zircon grains, specifically zircon. So zirconia, incredibly stable, and it bonds really well with in a zirconia dioxide formation. So it's a incredibly strong. This is talking about like a Mohs hardness of 9+. So this is approaching diamond, right?
Right.
Approaching diamond, but it's technically a ceramic, and it's a really low heat ceramic. So it when you go to say work a wax, it does not heat up, so it doesn't gum up this when you're working. That's what's really nice. So he did pass that along, and he was showing it to me, and we were using it together. So
yeah. Oh my gosh.
Cool.
I recently became aware of those. I don't have any myself, but I recently became aware of them because there is a wax worker in London who is doing, she just finished a couple of books. One is The Art of Wax. Her name's Elsa Tierney, and she had those in her book. And I was like, what is this? Because I hadn't seen them. And I know that they use them a lot in the dental industry.
Yes.
And I kind of found out about them at the same time at my dentist and from the book. And I was like, what is that thing? So yeah, but yeah, that's a great tool. We'll have to do maybe a tool tip on that. So
yeah, they're not bad. They're like $35. They're not.
And they last forever.
They last forever. I mean, a Mohs hardness of 9+ for ceramic is just awesome.
Yeah. Okay. Well,
sorry, I interrupted you. What were you saying? The last thing you said, Silas?
Oh, I just said it's incredible that you have a ceramic that's a Mohs 9+. I mean, that's just
right.
That's awesome.
Cool. Are they using space kind of on the?
Oh yeah, no, I mean, we have a couple aerospace clients, and they definitely use zirconia dioxide. I've talked to a few of them. That's actually something we can get into later, but it's the platinum applications in space are fascinating, especially some of the platinum group metals like iridium and the whole 919, 1912 isotope transmutation. Really cool.
Loving it? You're loving it, aren't you?
Oh yeah, I'm loving it.
All right. Thanks so much again. And we look forward to seeing you guys back at some point and doing another tool tip with us. So.
Oh yeah, we'll definitely be in touch.
All right.
Awesome. Thank you so much, Silas. It was lovely to meet you.